So what I'd like to do now is go over the assignment number 4, spec and skeletons. The purpose of this assignment, no surprise, is to give you a chance to get experience programming with the Java 8 completable futures framework, which you'll use, as always, to obtain, store, and transform images. And as usual, you can use your GUI, and soon we'll also have some regression tests for this as well, although they're not there quite yet. So what you'll do this time is there's a file called completable future crawler1.java, and that's what you have to fill in. So it's heavily commented. We'll look at the skeletons in just a second. And as always, there's a couple different ways to run it. You can either download the images from a website, or you can have it crawl from a local repository that's pre-installed on your device. You can kind of take a look at the sequential loops crawler to get some hints for how to do some of these things, although you're probably quite familiar with this stuff by now, having used that file for all the other assignments. For this assignment, you'll need to use the array collector, unsynchronized array, and synchronized array files, and I think you can just use pretty much what you had from the previous assignment. Just make sure that if there are any bugs there, you have fixed them, but hopefully there shouldn't have been any bugs because you addressed all those things in assignment number 3. And as always, there should be no loops at this point because we've already done, or you'll be able to use the completable futures features and recursion to avoid having to do any looping. You can get the skeleton code here in assignment number 4 in my GitHub account. Hopefully that's easy for you to do at this point. Just pull it. And as I mentioned, we don't have the unit tests integrated yet. We're finishing them off. They should hopefully be there in a day or so. So ideally, all you'll have to do is just do a git pull, and you'll pull the new autograder and unit tests into your repository from my repository, and it should work fine. We've been covering completable futures for the last few weeks, so I think you can get lots of stuff from the CS 891 website. We'll cover a few more things today that may be helpful for the assignment, but all that stuff should be in pretty good shape at this point. And there's also some great articles that talk about completable futures and videos that you can take a look at on the website as well. And if you have a chance to get the Java 8 in Action book, they've also got really good discussion about completable futures, which will give you even further insights into how to program it effectively. This assignment is a lot harder than the previous one, for sure. Assignment number 3 was pretty simple because we were just taking essentially the overall design from assignment number 2, getting rid of the fork join pool, and letting the parallel streams framework do all the work. So it wasn't very hard at all. I think hopefully that'll be reflected in the grades. We'll get back here later this week for assignment 3. Assignment 4 is a lot more complicated. So you'll have to really think about it, read the skeletons carefully, and ponder what is being asked, because it's got a lot more moving parts, and they're kind of weird because they're using asynchronous programming. All right, so with that in mind, let's go over and take a look at the skeletons for the assignment. As I said before, array collector and synchronized array and unsynchronized array should basically be cut and paste from what you did for assignment number 3. And that means the interesting stuff is going to be lurking here in completable futures crawler 1. So as usual, there's a bunch of to-do tags, which you can see if you're good at using Android Studio. You just look for the little blue things, which are the to-do stuff. So one thing you'll have to do is come up with a way to have a completed future that stores the value of 0. So if you go back and take a look at some of the slides we talked about recently, I think it was from last week, you can see how to do that. There's a sort of the entry point into this class is this perform crawl method, and that's what's going to actually crawl. As you can see, it gives the URI as the string and the depth count, and you have to implement this. What this says is perform the crawl asynchronously, wait until all the processing is done, and return the result. So you'll have to sort of think about how that's going to work, and you can call some helper methods. That's kind of the hint here. So here's a helper method that you can crawl, and I think you'll need to, let's see, I think you may need to use, well, we'll come back and see that, but this is what you have to do in order to implement perform crawl. Here's perform crawl async, which is what perform crawl is going to have to call. And this method does the checking to see whether you've exceeded the depth, in which case you bail out and return M0, which is that completed future that's given a value of 0. Likewise, if you've already visited a particular URL, you just skip it. And then the last thing you do here is invoke the helper method, which does the actual work. Here is perform crawl helper. I have implemented the guts of this, leaving you with all the details to implement. I've implemented the basic functionality, which is as follows. You start out by getting the page indicated here with the page URL variable. Asynchronously, you have to write that method. We'll look at that in a second. So that'll give us back a page future. And then the next two lines of code here will actually be able to run in parallel once the future has completed. So we're going to get the number of images on the page, rather, you're going to get the images on the page and the number of images on the page asynchronously using the page future. And likewise, you're also going to use that same page future to crawl all the hyperlinks on the page asynchronously. So the two things you're going to be doing in parallel asynchronously is downloading and processing all the images on a given page, on the page that you just downloaded asynchronously when it arrives, when it completes. And you will simultaneously use the completable futures framework to recursively crawl all the links reachable from a given page and do all the same processing on those images. So that's the two things that will go on in parallel. Notice how both of these helper methods, get images on page async and crawl hyperlinks on page async, return completable futures to integers, which will be the counts of how many images were downloaded and successfully processed on those pages. And then those results are going to be combined together in order to create the final result. So I've given you this basic structure of the code, and then you have to implement all these helper methods. Here is get page async. What get page async needs to do is it needs to load the page asynchronously and return a completable future to that page. So you'll have to think about how you would go about doing that. And of course, you can take a look at the synchronous version of all this stuff to remind yourself how you load a page synchronously. And then you can sort of think about, how would I use completable future factory methods or a factory method from completable futures in order to be able to initiate the downloading of that page asynchronously. So you should know how to do that by now because we've talked about that a number of times. Here is the get images on page async method. So this is given a page future. And what it's going to do is it's going to return a completable future to an integer that indicates the count of the number of images that were downloaded and processed on this page. And this method should call get images on page and process images, which are two methods further down that we'll look at in a second. And it should call them asynchronously via a fluent chain of completion stage methods. So you'll have to go and take a look at the various completion stage methods that we've talked about, things like then apply and then compose, or then apply async, or then compose async, or whatever, things that we talked about at length last week when we went through all the details of these things and figure out how to implement that. That's fairly simple. Then down here, we have to implement crawl hyperlinks on page async. And what this does is it takes the page future and the current depth, and it goes ahead and calls the crawl hyperlink on page method asynchronously. So you'll have to figure out how to do that. And it should come as no surprise that the trick here is to use the various completion stage methods that we've talked about, like then apply async or then compose async and so on to do that. And then here's combine results async. You've seen an example of something like this where you'd have two futures. One is the images on page future, this guy, and the other is images on page links future. So those are the two futures you get back from those other two asynchronous calls. And then we're going to go ahead and wait for them both to finish and then combine their results. So you have to write that code. That's sort of just a one-liner, not too complicated. Here's where things get more fun, though. So crawl hyperlinks on page. this takes the page that we've got and the depth, and it goes ahead and crawls the hyperlinks on that page. Now, a couple things to note here. This call itself will run synchronously, but it's going to be calling a bunch of asynchronous methods. And itself will be called in the context of an asynchronous operation. So it's invoked using an asynchronous operation, but it runs synchronously, yet it calls asynchronous methods. It's pretty crazy. So here are some of the methods that you'll need to use. You'll need to go ahead and take the images, you'll take all the hyperlinks that are on this page, and there's a method that you hopefully already know from looking at the other example for being able to get access to all the hyperlinks on a given page. And that'll come back as I think it's an element object, or elements object. And then you'll stream that, so you'll turn that into a stream, and then you'll go ahead and call map, and you'll end up recursively calling back to do all these other things recursively by, I believe, calling, let's see, perform crawl async. So you'll end up calling that recursively, and that will end up launching all these recursive calls to download the various pages referenced from the list of hyperlinks on this page that we have. And you'll also end up then collecting those things using something called futures collector stream, which we'll talk about shortly. And we'll use future collector stream to return a single future to all the futures that are downloading in parallel. And then you'll also go ahead and use some other magic in order to convert all of that stuff into a single completable future to an integer that will keep track of how many images were successfully processed doing the recursive traversal. Then we have process images. So this one works for the recursive portions. This works for a given set of images on the page. And this will also essentially use other methods to download and store each of the images in the array of URLs asynchronously and transform those images. So once again, we'll have a little stream here that'll do this. And here's transform image async. And transform image async is going to basically asynchronously return a completable future to a stream of images that correspond to transforming a given image when it's been downloaded, when it successfully completes, when this image future completes. It'll go ahead and asynchronously apply the various operations to transform the images asynchronously. So there's a bunch of crazy, wacky things going on here that you'll have to look at. So as I said before, this is a much more complicated assignment than the previous one. So I strongly recommend you start early. As I said, I'll have the skeletons out shortly, or sorry, the new tests out shortly, so you can unit test it. But it's definitely by far the most complicated assignment, and that's why we have extra time to do it. Okay, so that's a quick overview of the assignment. I'll send out email or post a message to Piazza as soon as we have the new skeletons with the test. But in the meantime, start taking a look at this and go back and take a look at the slides, the videos where we talk about the various types of completion stage methods and factory methods and the arbitrary arity methods and so on. We're also going to talk a bit about future collector stream in some upcoming videos, and this is very interesting, cool example of something called arbitrary arity methods, but I'll cover that more in the slides in just a second.